Okay, that brings us to the Q&A section. And so if anybody has a question, please plop it into the Q&A box at the bottom. And I know we had a few that Paul answered in the Q&A section by typing a response, but I actually want to bring up a couple of those questions again, just because I think they're pretty key. Everyone, all the participants can turn on your cameras so we can see all of you. I also want to bring in here Keith Gobert, my colleague with the Canola Council of Canada. Keith is an agronomy specialist. He's also our insect management lead. So there we've got Keith, we got Hector, we have Paul, and we have Sean. And Paul, I want to go back to you. And again, these are questions. I've got two questions here for you. Maybe we'll just do one and then we'll cycle back. But this one is from John, and I want you to answer it live because I really think it's important. John asks, what type of messiness is better? Many small patches or a few larger ones? What's your thought?
Yeah, thanks a lot for this question. I think we can say that many small features, that's many small wetlands, let's say, or many small patches of trees, that's going to create a lot of edge. And one of the real key messages we got from our satellite, the story that I told you there, is that right up against the edge of a wetland or a patch of trees, you're going to see a drop in yield. And I mean, and growers know that. They've seen that. They can, when they scout the crop, they see that the plants near the edge aren't necessarily doing as well. So that's not a big surprise. But I think what we are realizing, and we can actually model this, is there will be a sweet spot. So I think we can say outright, lots of small little features probably is going to give you too much edge. But there's going to be a sweet spot where we have fewer features of a larger size that are going to, spread the wealth, if you like, across that field. And we could actually, if you like, design an ideal field based on what we know right now. And that's certainly an exercise that we are in the process of trying to do. But I know this is unsatisfying to those who want to know, what do I do tomorrow to my field? And I'm not comfortable yet saying, do exactly this. I am comfortable saying, though, you need to keep as much of these messy areas as you can, to provide homes for beneficial insects. But you want to make sure that the fields around you are also have crop in them too. So we know that when you have too much mess in your field and the fields around you aren't messy, that actually is the ideal sweet spot. So a complex story, I agree, but it does tell us that animals or ecosystem services based there are actually doing something to our crop. Hope that answers.
Yeah, I think John points to a logistical question. I mean, we've got large field equipment, maybe not getting larger, but there was quite a growth over the past couple of decades. Just negotiating around some of these many small areas, many messy areas might be easier to have just a few big ones. Mind you, guidance and on-off of application is getting better. So there's that. But one quick one follow up on that, Paul, though. You said about other crops. Now, are you saying rotation, like so a wheat crop beside a canola crop beside a pulse crop, or does it really matter what the rotation is or what the border crops are, or just that there's other crops?
The studies we've done did not look at what the other crops were. So we just know that if you're in a district, if you're in the part of the prairies where there aren't a lot of crop fields around, adding more mess to your field is not going to help, and it might actually hurt. If you're in a part of the prairies like southern Alberta, where there is not a lot of mess, adding mess to your field is likely to help. So that's really another way of framing the message.
Just looking at the questions. So we've got a few other ones coming in, which are good. So we'll come back to you in a sec, Paul, but I want to go to Hector and ask the question about the trap crops. And thank you, Hector. Hector shared a document in the chat if you want to download that. It's a bit of a trap crop I didn't actually download it yet. I will later, but maybe a bit of a recipe on how to do that. Hector, do you want to take a minute and describe how a trap crop might work for cabbage seed pod weevil management?
Gladly. Yes, so a trap crop is a very old concept that has been used for ages, and it's especially very common in other countries. The idea is that you have either a crop or a different crop, to be the same crop at a different stage, but basically it's more attractive to the insect pest where you can concentrate it, and you will leave the main crop alone, or at least you will have a reduced abundance, and you actually can control it in the area where it's concentrated. So for cabbage seed pod weevil, it actually works quite well because the weevils are attracted to the crop at the flower stage in particular. So if you plant a canola variety that will flower earlier along the perimeter of the field, and when we did this work about almost 20 years ago now, we were actually using Polish canola on the borders and Argentine canola in the middle, but we also used the same cultivar, just planted a few days, well, a week sometimes. Now there is such a wide array of cultivars, and most of them are now shatter resistant. They vary in the flowering maturity. So if you choose the right cultivars and you plant them a few days apart, you actually will obtain that about a week time window. That would allow the cabbage seed pod weevil to get concentrated along the borders, and then you can spray it there, and you save 90% of the insecticide amount, also the time, and you're not killing the beneficials in the entire area of the field. So I think it's a potentially very, very beneficial. And
Hector, would that work for flea beetles as well? I know planting strips of crop before you plant everything else is a real pain, but if you could trap your flea beetles, your early flea beetles in an early crop, and then spray them out, and then spray the rest, or plant the rest of your crop, would that be a strategy as well for flea beetles?
Yeah, we tried that to some extent, not very thoroughly, but it didn't work. The flea beetles actually flew over the crop and went into the main crop. So flea beetles are a little bit tricky to outsmart. So it didn't work quite well for us when we tried it, but we actually haven't done a very thorough study, but we also tried a barrier crop of yellow mustard because they don't like yellow mustard as much, and again they seem to fly over and go to the crop. So no, it doesn't seem to work for that. I just want to say very quickly that I'm quite excited to. There is now a new development in terms of AP vectoring, where people are actually using honeybees and pollinators to vector things like Boveria bassiana, pathogens that can kill insects. And I think that even has better potential to even get away from using more insecticides. You could probably use honeybees to deliver pathogens to Lycos voles and cabbage seed pod weevils in the trap strip where it's concentrated. And that might be even a more integrated and more environmentally friendly, more sustainable way to manage this crop pest. And I'm thinking and toying with the idea of applying for funding to do this in the next cluster science cycle.
Okay, so I'm going to throw that one to Sean, but I want to get Keith in here first. Sean, think of how your lab might help identifying insects that could vector pathogens. That's really cool. Okay, just wait for a sec, because Keith has been smiling, and I want to see if Keith has anything to add. Keith?
No, actually, sorry, I've got some dogs in the background there, but hopefully you can't hear them.
Yes, we can.
One thing that I really liked was Sean including a paper from Europe that indicated we don't really have that many pests, and we were talking about that before the webinar started. That based on our winters and the fact that we're relatively geography isolated, we don't get a lot of practice with insects in canola, and we only manage what we're aware of as a risk. So insects haven't really been that much of a problem for us. And if we think about what our native insect pests are, Bertha armyworms spring to mind in terms of canola, and the rest are introductions. So Sean's made me a little nervous that he can bring in things from a long ways away and carefully contain them, but I do realize we do need to do the work ahead of time.
Okay, so that's perfect. Thanks, Keith, for that. So Sean, we got a couple of questions for you before we go back to Paul, but take a stab at that one about the vectoring using insects to vector pathogens?
Well, so the reason I was so excited that Hector mentioned that is that, in fact, that is one of the design intentions of the new facility. So we actually built that with that particular project as one of the things we intended to do. And so we've already been thinking about that actually quite a bit. But the issue comes back to exactly what I was sort of describing, which is that in many cases, what you need to do is you need to identify the virus that will effectively control the particular pest you're interested in, assuming a virus, which is what we're particularly interested in doing, is insect viruses. You obviously don't want to release that into the world, because if you pick the wrong one, it might start killing the beneficials. It might kill other things that are neutral, right? It could go after things that aren't helpful. Why this facility is helpful is just that. It allows us to do this kind of work in a way where we don't have to think about what happens if one of our critters escapes. So the answer is we already, in fact, are thinking about it. We've actually several times tried to get funding for it already, and people don't particularly like the idea because it sounds too crazy to them. It's a little too sci-fi. But it is a thing, and it is something that several people have been, including Hector and others, are thinking about how to do. So there's the answer, is that I don't have to think too much about it because it's actually in the proposals in some cases for funding this.
Well, that'll be really exciting to see what your lab comes up with. All right, here's another one for you from Harry. And your lab reminds me of the National Microbiology Lab in Winnipeg that deals with human diseases, but you're the insect version. Yeah.
Yeah, exactly.
Right, so exactly, yeah. So Harry asks, what insect pests fall into your forbidden category, and what kinds of insects are allowable?
That's a good question. So I guess I would say it's not my list so much as it's the Canadian Food Inspection Agency's list. So, and their list, it's evolving, it changes. So you can actually go on the internet and look, but generally speaking, the list, the forbidden insects are those that either are not endemic to a particular area or are not yet established. And I showed you that little diagram. So there's some things that are absolutely forbidden. And then there's some that might be forbidden in one place and not another. And then there are a lot that you don't even think about. And so they're not explicitly listed, but you need a permit for them because we'd have to import them. So in many ways, the question is, can we import them? And often what will happen is, if I wanted to import them, say from Europe, so say I want to get one of the things that Keith doesn't want us to get, what we would do is we would either go to Europe ourselves when that's still possible, or you'd call someone there and ask them to send them to you, and you'd get a permit, and that permit would often say, well, you need to have a quarantine of certain level 1, 2, 3, in this case, most likely to 2, to keep them. And then we would say, oh, well, we have one of those. And then they would give us the permit, and that would allow us to get it. And those decisions can be made on a per species sort of basis, per permit basis by the Canadian Food Inspection Agency. It's kind of a long answer, but it's sort of a esoteric question and answer.
Right on. Thanks, Sean. Okay, so this is what we're going to do. We've got 8 minutes left. I've got a bunch of questions here for Paul, actually. So I think I'd like to try to get to 3, possibly 4 of them. And then I'm going to give each of the presenters 30 seconds or so at the end, just to recap their key messages. And Keith, I know you've got a key message you always like to say, so we'll give you a chance to make a concluding statement as well. But here you go, Paul. And this is a question that I've asked you before, and this comes from Autumn. Are there any particular plant species that you'd like to see growing in the messy spaces to optimize the benefit? Or on the other hand, plant species you don't want to see? So what are the best species?
You know, I'd like to be able to answer that question and tell you what to plant, but I can't, in all honesty. At the moment, we have been, because there's so many different plant species out there, and we need to do this across a big area, we've been looking at vegetation in terms of crop and non-crop. So that's very, very coarse. But I think that's definitely a question that we need to approach, and we need to answer it. So it's a good question, but I'm sorry, Autumn and Jay, I cannot give you one at this point.
Yeah, no problem, Paul. Okay, so let's go to Melissa's question. And this has to do with that yield drop right at the edge of a messy space. So do we know, and Keith, maybe we'll go to you, Paul, and then Keith, if you've got a quick agronomy thing to add. But Melissa's wondering, how do we, so I'm drawing a graph of the drop in the yield and then the increase in yield in that little border area, that edge area. Do we have any agronomy tips? Well, I guess, first of all, why is it lower? Do we know? And then how do we fix that to just increase the benefit of these messy areas? Paul, then Keith.
You know, I won't answer the agronomy piece because that's not my expertise, but I can say that you know, the bump does balance out the drop, but whether it gives us a boost to significantly overcome the loss, I think depends on a lot of factors. And the questions we had in the chat were often about what should the shape of those messy areas be? How much edge should we have? And I've answered them there, but I think it really is a complex interaction between the size and the shape of the feature. And then Keith, please go ahead with the agronomy.
Not a lot to add there, Jay. Some of the benefits of those messy edges, we've already talked about ecosystem services. Some of the logistical issues of you know, sectional seating or the ability to turn boom sections off and on to avoid overlaps are really problems in those fields that have too much or have a lot of small patches. So growers already know that. The message that you're probably thinking I'm going to tell you is, particularly when it comes to insects, we really lose track of what's in the field. If the field looks in the road, often we have growers that are happy to leave it there. So scouting and making sure we know what's going on for insect pests, diseases, anything that might be going on in that crop will always improve our ability to manage it and understand what's there this year or what might be coming next year. So if you're looking for a final message from me, Jay, it's always scout.
Well, we'll come back to your final message and you'll be able to repeat that again. Okay, Paul, this is another one for you. And this is a really good one from Cameron, asking about ditches as messy spaces, ditches, road allowances, that kind of thing, very handy messy spaces. Do they qualify as beneficial messy spaces? And then part B to that question is, what happens to the benefit if we mow the ditch? So do ditches count, and what happens if we mow them, Paul?
We counted ditches in all of our work. In fact, we sampled in ditches we found lots of beneficial insects in ditches. We looked at ditches when we looked at the effect it might have on yield. So I would say, based on what I've told you, ditches qualify as a messy space. Whether you mow them or not is a complex issue. We know that mowing ditches can actually benefit bees, but I think it's very likely not to benefit your natural enemies. You know, they might need to find some flowers there that have nectar in them. If you're cutting the flowers off, there's no nectar for these natural enemies. And, you know, your beetles that are eating your pests may also need that. Hector, you going to add something there?
Yeah, just a specific example with the wheat stem softlight, the parasitoid Bracon cephi, that actually the ditches and the grasses there, they're actually a refuge for that pest. So in years when the softlight is low, it looks like it persists in those ditches. So if people are mowing them, they're probably destroying the Bracon cephi parasitoid.
Oh, so that's good news. So if you live in a municipality or county that never mows the ditches, they're actually doing you a favor. Okay, let's squeeze in one quick one, and this is also for Paul and for Hector. Herb asks, could judicious use of trap crops result in the same benefit as messiness without the drawbacks? So crossover question for both of you guys. Don't know whether you can answer it, but why don't you take a stab at it? Trap crops as a messy benefit.
I'll say, yes, let's try it. Hector, let's do it.
I agree also. I think as much as you can, diversify your agro-ecosystem, and adding this bit of heterogeneity, you know, more diversity, more complexity, more messiness, you're going to have crops at various stages. I think that's going to help you.
Okay, great. We got one more minute, but that's okay. We'll go 2 minutes over. We'll give each of you a last word. We're going to go in reverse order. So Sean, what's your last word?
What's my last word? My last word is that pest management, both pathogens and especially insects, tends to be a reactive process. We spray fields after we see things that we don't like, and we start developing the ways we manage them only after we start becoming aware of problems. And that's a very bad way of doing things. And so what we need to do, and that's both as growers and scientists, is to start thinking about it the other way. And that is to start thinking about how do you make the world something where these won't become problems. And that is the link between everything we're talking about. That is why all the work Paul's doing is helpful, because it is keeping these areas that help make so that there are no pest problems. It is doing all the things Hector's talking about, making sure you keep your beneficials around and scouting, and it's doing some of the things that we're trying to do, which is to have the tools already available. So when you start seeing problems, you know how to handle them rather than having them become problems. So that is my takeaway, is to remember that really one of the keys that we need to do is to switch from being a world where we react to problems to a world where we try to anticipate them a little bit and do those things that are sort of prophylactic and preemptive, and that will save people money. I'm quite certain of it, for both inputs and because of the environmental impacts being reduced.
Great. Thanks, Sean. Hector.
Okay, I hope I don't repeat or don't steal Paul's thunder with my take-home message, but I'm going to say think big, think long-term. And when I say think big, it's think not just of even your own field or your own farm. Think of your entire community of neighbors and yourself, about what people are planting around you, what you're planting. And think long-term is think of what you're doing today in your field when you're spraying for CABC for weevil. That will have an effect on your neighbors, your own fields beside you, and in the future also. If you're going to kill a lot of parasitoids, hopefully you're going to conserve them rather, so that you build up in that community of natural enemies and pollinators, and you have a vibrant, healthy, diverse ecosystem. That's it.
Good. Thanks, Hector. Paul, and then Keith.
I think my message is going to be keep those messy areas. If you're on the fence, or literally if you're on the fence row, keep the messy area rather than get rid of it. The balance of evidence that we've collected to date suggests that yes, this is a complex story and it's a hard one to tell in 15 minutes, but the balance of evidence suggests that messy areas are an insurance policy. They're an insurance policy by creating reservoirs of those natural enemies that will come into play in bad years. And that's also what Hector says when he says, think long-term. You got to think that some years are going to be bad and some years aren't, but it's for those bad years in particular that those messy areas are going to provide that insurance policy. So if you're on the fence, don't take out the fence row.
All right. Thanks, Paul. Keith.
I think Paul's practiced that line. You get a bit of an idea what I'm going to say there, Jay, but to apply it to this panel, it might be a little different. Is there's a lot to learn about insects, and while scouting is my top piece of agronomic advice, almost regardless of what the question is, one of the things that you might want to consider is while you're scouting in your field, swing that sweep net in the ditch, take a bit of a look at what else is around in terms of ecosystem services, because I know for a new agronomist, the first time they swing a net in a canola field, it's actually a little bit intimidating in terms of the variety of things that are in some of the fields. Some of the fields are restricted to a single pest species, but there's a lot of beneficial insects you can find in the field. But the first time you swing a net in a ditch, there's a whole world of entomology that opens up for you. And I think it's really eye-opening to understand what's in those messy bits. And that's maybe a challenge that we can lay out for some of the producers and scouts out there.
Great. Thanks, Keith.